Okay, concept of limits, rates of change. Now, the following is a formal approach to limits. The following is the graph of fx is shown. You have a line over here which is ending at here. This endpoint is included. This hollow dots are not included. So limit is x tends to 6. Now when you're finding the limit is x tends to 6, your left hand limit and your right hand limit should be the same. So your 6 is, this is limit as x approaches 6. So this is your 6. So you approach 6 from the left hand side. So when you approach 6 from the left hand side, what value will you approach on the y-axis? 3.
3. Yeah.
When you approach 6 from the right hand side, what will you approach?
9.
Again 3. Why? You will come at the same place. No? Suppose you start.
Okay.
So x approaches 1. First you take from the left hand side. X is approaching 1. 1 is here.
Yeah.
As x approaches 1, your y approaches what? -2.
Yeah.
If you approach from the right hand side also, it will still approach -2.
I don't know, whole thing of right and left. How is
right and left is
right.
Right is from the left hand side, and this is from the right hand side. You approach from here also.
So it's always on that red line.
It's always on the red line. You move on the red line. So this approach is 6 from the left hand side. This is from the right hand side.
Okay.
Now x approaches 0 from the left hand side. From the left hand side, look. From the left hand side, when you're approaching from here. You're approaching 2. From the right hand side, the graph is here. You're approaching 0. From the left hand side, you're approaching -5. So limit does not exist. Because from here it is 2 and from here it is 5. So from the left hand side when you approach, it is approaching 2. When you approach 0.
Okay.
When you approach 0 from the right hand side, you're approaching -5.
It doesn't have to be on the same line.
It has to be on the same line. Then the limit exists.
Yeah.
Over here you say limit does not exist.
Yeah. That's like the previous two, the left and right were on the same line.
Yeah.
That's why it ended up the same.
In fact, in the first one, if I ask you what is f6, your f6 is also 3. The value at 6 is 3.
Yeah, yeah.
Okay, if I ask you what is f of 1?
F of 1 is...
f of 1, here, this one.
Would be, 1 second. Yeah, that.
No, it's not defined. There's a hole.
But why can't you go up? Why can't you go higher?
No, f1 is at this value. At this value, there's a hole in the graph.
Oh, but I understood that, but why can't you go up? Why did you go down?
Because you have to go to the graph, no? Up there's nothing. Up there's heaven.
Yeah.
So you have to go towards the graph. Okay. Then f of 0.
But the other line on the left, that straight line is part of the graph.
It's part of the graph.
It's a...
Yeah. F of 0.
Negative 5.
Negative as there's a hole.
This is not included.
So negative is not included. But do you have 2 being included?
Yeah.
So f of 0 is 2.
So you do the one that's included, obviously.
Yeah.
Obviously.
You do the one with. Okay. So to begin with, let's first draw the horizontal and the vertical asymptote.
So your horizontal asymptote would be 3.
Horizontal asymptote y is equal to coefficient of x in the numerator upon coefficient x in the denominator.
That's 3.
So y is equal to 3. So y is equal to 3.
Isn't the horizontal asymptote?
Yeah, the answer is the horizontal asymptote.
Yeah.
You are right. So this basically is the horizontal asymptote. So because as your x gets larger and larger, look, as your x will get larger and larger, this graph will approach this horizontal asymptote.
Yeah.
Correct? Acha, on this side, as your x gets smaller and smaller, this will also approach this horizontal asymptote.
Yeah.
So that's your limit. So what happens when your x gets larger and larger? What will your y approach? What happens as the x gets smaller and smaller? What will your y approach? So y will approach 3.
Okay.
Y will approach 3. So therefore that's the limit. That's the limit.
And is that thing with x approaches 50? That's important.
So as your x approaches, in the next one, you have to find out the limit of the function. Your function is x square minus 5.
Yeah.
This is your function x square minus 5.
Yeah.
Correct? Your limit as x approaches minus 2. Then x comes closer and closer to minus 2. You come closer and closer to minus 2 from this side. What value will you reach?
-1.
Negative 1. You approach closer and closer of minus 2 from this side.
Same thing.
Negative 1. So what is my limit? The answer is minus 1.
Oh, you know what I was doing? You're recording. Oh, no, she said.
It's not in the formula book. It's like a slope.
Yeah.
How do you find slope?
Why do I try?
Yeah. So the average velocity will be the change in y upon change in x.
Yeah.
So function, the value of the function at t2 is y2 minus y1, basically like that, upon x2 minus x1.
Okay, fine.
It's a slope, yeah. So find the average velocity. T is equal to 0 and t is equal to 2. So what will the average velocity be? F2 minus F0 divided by 2 minus 0.
Yeah.
What is F2? What is FT?
F of t will be
T square minus 5. So F2 will be what? 2 square minus 5. 4 minus 5 minus 1.
Yeah.
F2,
so F0 would be negative.
F0 is negative 5 in bracket. So that will be minus 1 plus 5 upon 2 minus 0 is obviously 2. 4 over 2, the answer is 2. Chalo.
That's 3.
So average velocity again here will be F2 minus F1 upon 2 minus 1. So F2 is negative 1 minus 4, because if you put 1 over here, yeah, it's minus 4 divided by 1. Correct?
Yeah.
2 minus, so that's how much? Minus 1 plus 4, which is?
Yeah.
Correct? Now this one, same way you do it. So average velocity will be what? F2 minus F 1.5.
Yeah.
Find out F of 1.5. You can use your calculator. Don't waste your time.
It's negative 2.
Huh?
Negative 2.
Negative 2. How negative 2?
1.5 whole square.
1.5 a whole square minus 5. 2.25 minus 5.
Oh, so what about you? Yeah, sorry.
2.25 minus 5. How much is 2.25 minus 5? Minus 2.75?
Yeah.
Correct?
Yeah.
Upon 0.5. I'm erasing this rough part. So that will be how much? 1.75 divided by 0.5.
Yeah, I do that.
How much is that? Yeah.
3.5.
3.5.
Very straight. It's just like a lower formula and straightforward.
Yeah, but what are we doing is, see, we are taking this point, see, we have kept this fixed as 2, we are taking this point closer and closer to 2.
Yeah.
So we are taking a limit, so we are taking the second point closer and closer to 2. And we are seeing what is this answer approaching.
Yeah.
We are seeing what this answer is approaching. So first my answer was 2, then my answer is 3. So if I take closer and closer points to 2, I'm seeing what's happening.
Answers becoming
larger. Yeah, now the average velocity for the next one. So F2 minus F 1.9 divided by 2 minus 1.9, correct?
Yeah.
So work this on your calculator, come on.
0.
So if you work it out, minus 1 plus this on your calculator worked out to be 1.39 upon 0.1. So how much will that be? 3.9. Correct? Now we take the next value. So for this one, what will the average velocity be? If we take 1.99, so F2 minus f 1.999. No, but you're taking it even closer. So how much does it approach? Find it out. So find this out on your calculator.
Yeah.
See, this would be minus 1 minus 1.100399, correct?
That's okay.
And if you work it out, 2 minus this is 0.111, huh?
Yeah.
0.001, correct?
Yeah.
So I am getting 3.999. So now you estimate. Look, you're taking the second point as close as possible to 2.
Yeah.
What is this value approaching? First my answer was 2, then my answer is 3, 3.5, 3.9, 3.99. So what is the instantaneous velocity? So can I say the instantaneous velocity will be 4?
What do you mean instantaneous?
Instantaneous velocity is velocity at t is equal to 3. It's like the speedometer of your car. Your speedometer of your car gives you the instantaneous velocity. So we know that these values are approaching, coming closer and closer to 4. Therefore, the instantaneous velocity will be 4. It's coming closer to 4 now. 3.99, you're coming closer to 4.
Yeah.
So that's the concept of limit. So listen, the whole idea is this. We want to find the instantaneous velocity slope of the tangent.
Yeah.
Now what are we doing is we are taking a second point. Now this is the chord.
Yeah.
And this is your x, this is your second point, x plus h. We have to get this point closer and closer and closer.
Yeah.
So as you get this point closer and closer and closer, your secant will become a tangent.
Okay.
That's the whole idea. That's your instantaneous velocity. Velocity at that instant of time.
Okay.
So the first derivative of the formula is your f dash x is equal to limit as h tends to 0 f of x plus h minus fx upon h.
Yeah.
That's your first principle.
Yeah.
Correct? So now, chalo, so let's find out using first principle. Now this is not there for SL, but your school is doing it so that you may get a deeper understanding of the concept in the opinion of your teacher. Now, so if you're finding the derivative, so I'll use f dash t is equal to limit as t tends to 0, as h tends to 0, f instead of x there's a t plus h minus ft upon h. This is ft, so ft I know. What is ft plus h? If this is ft, what is ft plus h? I'll replace this t by t plus h. I'll replace the t by t plus h. So what will ft plus h be? Tell me. T plus
H the whole square minus 5.
minus 5. Can you simplify this? T square
Plus h square plus 2t minus 5.
This I'll put here. The entire thing I'll put in place of ft plus h. Correct? So limit as h tends to 0. This is t square plus h square plus 2th minus 5 minus, what is ft? This is my ft. Correct?
Yeah. T square minus 5.
Upon h. So limit as h tends to 0. T square plus h square plus 2th minus 5 minus t square plus 5 divided by h. Open the bracket, the sign changes. So plus t square minus t square cancel out. Plus 5 minus 5 cancels out. Limit as h tends to 0. Remove h common.
Yeah.
What will be left with?
H plus 2t over,
Upon h.
So we have h plus 2t.
So this and this cancels out.
So limit is h.
Now remember, your h is very small. H is approaching 0 means h is very small. It can be ignored.
Oh.
So answer is 2t.